So basically, the stuff that I'm going to cover is the features of the language that I think will be like useful for system admin stuff, and then also some kind of more pragmatic stuff that I think you'll pick up a lot easier. So if you don't already have Python installed, I put some papers up there for you to grab for VMs if you want to do that. You should be running like at least like 2.6 or 2.7. So if you do python-capv, just make sure that you have one of those versions. If you have 2.5 or older, you should probably upgrade. So yeah, these are just instructions for installing and upgrading Python. Everyone pretty much have 2.7?
Yeah.
All right. The next thing you need is pip. Pip is a package manager for Python. So you'll be installing packages, and you'll need pip to do that. You might have easy install. If you do like which easy underscore install, you can use that to install pip if you don't have it, or use your system package manager. But you should just be able to type like pip, and it should come up. Just so you know how like pip works, so this gives you access to the whole ecosystem of Python like packages. So it pulls from this website called PyPI, Python Package Index. So what you'll have to do is you have to know the name, or you can do, I think it's pip list to get a list of packages, but it's not very useful. So you want to go and like find the package name that you want. So a common one is a HTTP requests module. It's just called requests. So you do pip install requests, and that'll install the latest version on PyPI into your system. You can specify like an actual like version. You can do like greater than, less than a version. So that's how you do that. You can pip uninstall requests. Pip freeze will show you all the currently installed packages in that environment. And then pip search is how you search stuff. I never really use this though, so not really that useful in my opinion. Some reference material. I'm gonna send this link out for all the notes after we're done, but probably want to check out some of these links. The Python docs is just docs.python.org. If you go there, they have like a lot of information that you can start diving into if you want to go deeper than what we covered today. There's a tutorial which kind of just skims the surface of the language, gets your like feet wet. A really good resource is this thing called the Hitchhiker's Guide to Python. They have like all the community like knowledge and stuff that you have to pick up, from experience. They kind of like document all that in this place. So if you want like best practices and stuff like that, you just go there, and they have like I think I sent out the installation instructions I got off there. It's a pretty good resource. Zed Shaw has this book called Learn Python the Hard Way that a lot of people say is good. I've never actually gone through it myself, but that's another way that you can get some experience. Read the Docs is a website for third-party packages, their documentation. So if you go there, just pull it up here real fast. So they have like a search. So say I want to get the docs for requests. So requests Kenneth Reitz, that's the one I'm looking for. Click there, it gives you like all the versions, like historical versions that were built. And then you click here, they got like PDF versions, they got web versions and everything. So it's kind of a good resource.
Read the docs?
Yeah, read the docs.
What?
GitHub.
How did you get to that GitHub thing? Just go to Jason King?
Yeah, if you go to gist.github.com /
gist, okay.
Yeah, Jason Keane, and then it should be like the most recent gist that I edited. I should have sent that out before. Forgot.
I've created a public room in HipChat if you want to join it. Just learn Python, and it has the link into that.
So what are you guys' experience with programming in general? Programming in Python, maybe? Anyone have any experience?
Just some PHP, bash scripting, a little bit of Python. Whenever bash won't really do the job, if I have to work with arrays or whatever.
Yeah.
PHP, bash.
Yeah, you'll see a lot of similarities, I think, with Bash. The Bash-like language kind of falls over when you start doing more complex things. So that's part of the time as a system administrator, if you're writing scripts, you'll probably reach for something like Python. And I kind of tried to show the symmetries between the two. There's a lot of symmetries between the two. So my personal level experience, I've been programming Python professionally for about 7 years now. I've been writing code forever, so. But yeah, Python, early on I picked it up, just writing little scripts and stuff like that. And it's a really pragmatic language. It gets out of your way. There's not a lot of ceremony, not a lot of boilerplate that you have to worry about. You don't have to have an IDE or anything to use the language. So it's really productive language. It was designed to be like a middle layer between shell, which you use to get stuff done day to day, and systems programming, which is like static compiled languages. It's really great for fast prototyping, quick turnaround, no compilation. You just run the code interactively if you want, and it just runs as you write it, so it's really useful. So yeah, I'm going to go into language overview, which I think is probably going to be about half the material we cover, and then pragmatic stuff. I'm just kind of going to fire some stuff out there, and whatever you guys are interested in, we could mess around with that stuff. All right, so let's go over here. So first thing I want to introduce you to is the interactive interpreter. If you think about it, your shell is kind of like an interactive interpreter. So in this situation, you type in Python, it'll bring you up with a prompt with 3 greater than signs. And in that prompt, you can type in any type of Python expression or statement, and it'll return the result here. So let's go ahead and do that. You can see it tells you the version and type help to get more information or whatever. So you just want to type something in here like 5 times 20 gives you 100. So you can see how it's kind of like similar to Bash in that you type in commands and it gives you the result, and back and forth. They call that a read eval print loop or a REPL. And then when you're done with the session, you just want to hit Control D, which is like end of file. On the Mac or on the Windows, I think it's Control Z. Unless you're using Siglin, that's probably Control D. So yeah, it's similar to the shell environment. Like if I was over here and I typed in Bash, similar to typing in Python, now I have like a new subprocess, but this time it's Bash, and I can type in expr. What do I do? 5 times 10 or something, 20. Alright, give me, well, I think it has to be without quotes. There we go. So, and then you hit Control D and Bash as well to signify end of file. You can see how it popped me back into the parent process. So it's a lot similar to like Bash, the interactive interpreter. And again, you invoke the interactive interpreter by just typing in Python. That's it. So that's one way of like getting into Python. Most commonly, you'll run Python in an interactive session to kind of play around with things. And then once you get an idea of how you want to code something, or you've actually written the code because you've done it in the interactive interpreter, you can copy your code into a Python file with .py and save that, and then you can execute that with Python. So I'll just go ahead and show that. I'll call this mult.py. So I'm just going to type in here same code that we did before, 5 times 20. And now if I do Python, can everyone see that? Python mult, you can see same result. But this time it doesn't keep you in that read eval print loop. It just evaluates the program, prints the standard out, and returns you to your parent shell. So that's writing like a script. You also see in the documentation stuff referring to modules. They're pretty much synonymous. Module is like the Python file, but usually you treat modules as something that you import. So I'll show you an example here. If I'm in Python already and I type in import mult, which I defined as just a Python file in the same directory that I'm in now, you can see how by importing that module, it evaluated the module, put me back into my interactive interpreter. You can only do that once, because once it's imported and the import system caches it. So, but that's how you like import modules. I'm going to go ahead and edit that. Actually, I'll just create a new file called script.py. So here I'm just going to print out the result of this expression, which is 2, or will be 2. I'm going to define a variable here. I'm going to give a variable called name the value of the string JSON. And then I'm going to use print here. I'm going to give it 2 arguments. It's a statement. It takes arguments, a common delimited list of expressions. And I'm just going to say hello, comma, space, name. And that's going to print to standard out hello JSON. So again, I'm just going to do Python script.py. You can see how that works. So that's arithmetic, variables, strings, all basic atomic stuff to the language. Another way that you can run a script is instead of typing just Python script, you can type in python-i script. And what that'll do is it'll run the script like it would normally do, but at the end of it, it'll put you into an interactive interpreter with all of the modules, variables available to you. So same thing happened here, but now I'm in an interactive interpreter. And if you remember, I defined a variable called name. So I have access to that variable now. So these are just different ways that you can like get into Python, get stuff done. Similar, if you guys have written bash scripts before, you have like that hash bang they put at the top to the path to the bash program. You can do the same thing in Python. You don't even have to name it a .py file. You can just have a file that has a hash bang at the top, and you change mod plus exit, and then you can run it just as like a normal, executable. So if I import script here, so again, doing the same thing I did with that mult module, I just import script, and then instead of having everything in my interactive interpreter loaded into the current like module namespace, I have it like namespaced into the script symbol here. So if I do script.name, that's where name is stored. So it's kind of like, namespaces all the things. You'll see all modules are kind of like this, where you import a module, like OS, and then you have OS dot whatever.
How do you know what all those are?
It's a good question. If you do dir, it's like a built-in function. You have that available everywhere.
Yeah.
If you do dir on OS, it gives you everything that it has on there.
Okay.
So if you do os.wait, I'm guessing that's kind of like sleep. Where it takes an integer, maybe 2. What is it? I don't know what it is. But if you want to know what something is, then you can use help. os.wait. So this is an example of, I did dir on OS, I found this thing called wait, and then I want to know what it does, so I just pass that entire object, fully qualified object into help. And it tells you that it waits for completion of the child process. So it's probably has something to do with forking off processes and waiting for them. Also, if you do help on just OS, which is something I imported, it's kind of hard to read here, but it's kind of like a man page type thing.
OS in brackets there?
In
Parentheses. Yeah. So help is like a built-in function, kind of like dir, and you call it and you pass in anything, and it'll give you the documentation for that thing. All right, so you can run modules instead of running a script. You know, you run scripts by typing Python and giving it the path to the script, or you could pipe a script into Python. That's another way of, like, you know, getting stuff into Python. If you do -m, it runs the module in this module mode. So I can show you how that works here. You probably won't really be writing this, but I wanted to put it here because there's this module that you can import. If you just import simple HTTP server, you can see how you have this thing in the standard library that you can use to create a web server. But if you run it as a module, this Python-m simple HTTP server, you can give it a port as another argument, but by default it goes to 80,000. And what it'll do is serve up the current directory that you're in on port 8000. So you can see those files that we created. So, I mean, it's kind of useful if you want to, like, you know, quickly share files with someone. You just cd into that directory, run simple HTTP server as a module in Python, and it serves up the directory. I mean, there's other, like, you know, like PHP has its own, like, server too that you can run. Other languages, Node, they all have, like, servers built into the language, but this is how Python does its basic server. All right, so variables I kind of just touched on briefly. So name here is a variable. Variables are case sensitive. They're basically just labels that point to something, whether it's something allocated on the heap or something in the stack. It's just a variable. It's not a container that contains stuff. It's just a pointer to something in memory. As such, it doesn't have types like variables. I could show you here. Previously, I had something called name, and I gave it my name, Jason. But I could very easily just say name equals 1, 2, 3 and redefine that variable to be the value 1, 2, 3, 4. So it doesn't matter what type the variable is because variables don't have types. So the objects do have types. So if I do type on JSON, you can see that's a stir. And if I do type on 1, 2, 3, 4, it's an int. So the actual objects do have types. As a result, you get into situations where you want to do stuff like arithmetic addition on a string and a integer, and it's going to give you a type error. Python is strictly typed or strongly typed, so you can't add or do arithmetic operations on types that don't support those operations. So in this case, integer cannot be added to 1, 2, 3, 4. You can see there's kind of like an ambiguity. Do you want string concatenation or do you want to have 1, 2, 3 or 1, 2, 4 as the result? So you have to do something here. Either you have to cast that string to an int, or you can cast this integer to a string. So, but you'll see the type error that you get is pretty self-explanatory, So when you run into those situations, you're just like doing something where you have to change the type of one of the operands. All right, so the built-in types. So ints, you can just type in a natural number like that, and that's like an integer. Integers, differ from other type of numbers in that they're just, they're the natural integer set. So you can't have 2.4 as an integer, So sometimes when you get really, really long in here, you'll see Python converts it to an integer that has like an L at the end. It just lets you know that that's like a long integer. Doesn't really mean anything. You don't really have to worry about it. There's different type of literals for integers, so I'm using like decimal notation here, but you can say 0b, 10, you know, put a bunch of binary, and it'll give you the decimal value, the integer decimal value for that binary number. You can do hexadecimal using 0x, AA, BB, CC, gives you that value. So if you're doing like, you know, like IPv6 stuff, you know, you want to see what the actual integer value is for a MAC or address or something, you know, you can just type it in there.
Octal too.
Yeah, you can do octal, which is 0, I think just 0. Yeah, that's octal. I think there's another octal thing, I think.
So
0 lowercase
you
o.
can do like a 0 O and then like 777 if you're doing like changing permissions and things like that.
Got a question.
Yeah.
Why does Python always round up like really long decimal points?
So Python uses something called like floating point representation, and floating point isn't like precise. So you always have like you know, floating point error when you're dealing with floating point numbers. You can use this thing called a decimal. So if you do from decimal import decimal like that, you can create a decimal and give it a precise value, so you can go to infinite, or not, you know, infinite, but I got a Y in there. But you can give it as much precision as you want, and it'll maintain that precision.
Awesome.
So you can add this with, you know, 12, and you see it keeps the precision of it. This is like, it has a performance cost, so they don't do it by default. But if you need that precision, decimal precision, you just reach for that. Sometimes what I do is if you do from decimal, import decimal as D, then you just do D like this. It's a little bit of a shorthand. Yeah, that's a numeric type I didn't really cover because it's part of the standard library. It's not really part of the language. But you can import it and use it that way. Is there any other literals? There's a lot of literals, so those are the ones that you know you come in contact with normally. Bool, so you got like true, and you got false. I mean, these are just names that point to those objects, but like, you know, true is true, false is false.
There, maybe.
Maybe if you do false, true is equal to true, false. And then true will be false and false. But for most, unless you're doing some insane programming like Zach does, like, you know, you'll run into situations where false is true. So I brought up before floating point numbers. So if you don't do the decimal thing, if you just do like, you know, raw, you know, like floating point number like that, it'll give you the floating point number, but there's situations where when you were doing arithmetic on those numbers, or even if you just like put a number here, like you can see how that number is not the same as that number, you know. It loses precision, so you want to just keep an eye out for that. If you need something that's precise, you want to use that decimal. Complex numbers, I'm not even going to get into that because you probably won't run into it. But yeah, there's a built-in, I don't even know what the representation of it is. 12i plus, what is it? I don't know. It has built-in support for complex imaginary numbers, so you know, that's that. Strings we kind of covered already. In 2.7, the default string is a 8-bit, you know, ASCII value. The story in Python 3 is a little bit different. They made everything Unicode. But in Python 2, you have to ask for Unicode with a U prefix to the string. So, like that's like a Unicode string. Most of the time, you just want to use Unicode. You can do this thing that's like from feature import. Is it Unicode? Unicode underscore literals. So that'll make it to where any like normal string that you create is automatically converted into Unicode. If you want to do that for the entire file, you can put that at the top of the file and it'll do that.
What's the advantage of Unicode, like
Unicode, you get like all the crazy characters.
yeah.
I don't think you'll probably run into it, so just stick with the normal strings.
Oh, okay. I thought you said you normally want to put yours into Unicode.
As a programmer, and especially like a web programmer, like pretty much everything you want to do is in Unicode.
Oh, okay.
But doing system stuff, I don't think you'll run into it. So. Collections. So this is where it kind of gets interesting. So collections. The first collection is the list, which is just a collection of objects. They don't have to be the same type. They're 0 indexed. So say I have in brackets here 1, 2, 3, and then I could have the string hello, and let's just throw an object in here for good measure. So I got this collection. You know it's a list because it has brackets at the ends of it. You can even add in here like a nested list. They call this like homogeneous or homogeneous or heterogeneous. Yeah, heterogeneous because it has different types in it. In order to access something in that, so I'm just going to assign this entire expression into a variable over here. I call it our test list. And in order to get stuff out of it, you just use the bracket notation, and then you give it the index from 0 up to n. So say I want a fourth, I'll just say 3 because it's 0 indexed. So that'll give me the fourth element. It's kind of a little bit confusing, but you start from 0 and you count up. So the 0th would be 1. What's really cool about the bracket notation is they have this thing called slicing where you can do like, say I want from the 4th to the end, you can just do colon, and that'll give you everything from the 4th to the end. You can do from the 4th to 1 from the end, so that'll leave off this second list. You can get everything up to, but not including the last one. So there's a lot of different like little tricks that you can do with the slice notation.
Reverse the list.
Yeah, how do you do that? Negative.
Double colon.
Oh, yeah. Like that or negative 1?
Negative 1.
Oh, so that's like, so it counts from 0 and down. Yeah. So that reverses it. Another thing that you'll see a lot is this, to copy a list. So it looks like the same list, but it's actually a separate, list that was copied over.
What do you have to, so if you assign that to a variable, you now have a copy that you can modify or something?
Yeah, so I call it test list to, oh, that's not going to work. So I can append a new item onto here called Bob, and then test list 2 has Bob, but test list doesn't. So
how do you access stuff on the second list?
There's the nested list. So yeah, you could just do, what is it, this -1 to get the list, and then you can do like basically chain the indexes. So you can, with a index nested list structure, you just need to, for every list nesting, you just put an extra set of brackets with indexes.
To clarify, if you wanted to, since it's the 5th object, you could
Yeah.
also do 5 instead of -1. That just
Yeah.
represents the end of the list, right?
-1 will always give you the last element of the list, whereas 5, if the list expands, you'll get something different. So there's a lot of really cool stuff you can do with lists. I won't go into all of it right now, but I would say lists and dictionaries are like the core data structures of the language. Dictionaries a little bit more than lists, but both of them are very useful, very flexible. Use them a lot. So let's go into dictionaries. So dictionaries like lists that they use this little bracket, but they use the brace, the curly brace, instead of the square bracket. And then in here, you give it like key value pairs. So it's like the keys map to the values. So say I want to have like a dictionary that's information about a customer or something like that. You would say the first name, and you say that colon maps to Zach. And then you say last name Doe. So you can see one thing Python already did for us is like upcast all the strings in the Unicode. I think it's because we imported the So anyways, this entire thing is like one object, and if you want to access stuff into that, let's go ahead and sign it. Instead of like typing left on the interactive interpreter to get back, like you can go up, down, kind of like bash. So instead of like typing left to get over there, I'm just gonna do test dict is equal to underscore, and what underscore does is it gives you the last result of the last command that you ran. So in this case, it's going to be this dictionary is going to get assigned into that variable test dict. I do that because I don't want to like go up and like, you know, key over all the way over here and type it in.
Command A.
Yeah, I don't know the Emacs bindings. Yeah, Command A, I guess works.
In bash, it's exclamation point question mark using the last result.
Yeah, so it's similar to bash in that respect. So those two commands were equivalent there. So in order to index stuff on this test dict, like get stuff out of it, we just ask for the first name. I can type that. So it'll give you the value. You can see like the keys here were Unicode keys in the dictionary, but I gave it, I'm guessing, upcasted it to Unicode. I'm pretty sure that you can give it a string though, and it'll still give you the value. It doesn't matter if the key or string or Unicode, in 2.7 at least. Yeah, if you give it a string and the key was Unicode, it'll have a match. If you sign into a dictionary and you use a string as the key, and there's already a Unicode value in there, it'll use that one. So if you do test underscore dict dot keys, that'll give you all the keys, values, give you all the values. One thing about dictionaries is that there's no guarantee to the ordering of the values. In fact, like it's a little bit deterministic in CPython, but as soon as you grow the dictionary to a certain size, it reorders things. So you can write code that depends on the ordering, and it might work until the dictionary grows too big, and then everything breaks. So you want to like be aware of that dictionaries don't have any inherent ordering. They're just, this key maps to that value. So yeah, this is the help on dictionaries. Just go through some of these methods. So you can copy it. You can do this .get instead of using the bracket notation, and you can give it this second argument D, where it'll give you D if the key doesn't exist. It's kind of nice.
How'd you get to that help again?
So yeah, you just type in help, and then begin paren, then the thing you want help on, and then end paren. All right, so yeah, our test dict. So if I want, say, the middle name, which we didn't actually put in there, you can see how it raises an exception, a key error exception. If you wanted to test to see if the middle name existed, and if it didn't exist, don't raise an error, you can use get. And that's where you would pass in the second argument here if you wanted a default. So you can do that.
And you can just continually insert into the dict, whichever. Can you erase from it as well? So
yeah, there's a keyword called del if I want to delete the first name. So I do del test dict and then I'll give it the key here. It's the first name. So that deletes the first name out of it. See if there's anything else. Anything else you think is useful in dictionaries that you want to go over? There's a lot of stuff you can do with it. And there's other data structures in the standard library like ordered dicts. There's something called a counter, which is a dictionary that just counts how many times you put stuff into it. So there's a lot of like dictionaries are, I would say, the core data structure to Python. All the object-oriented stuff, it's all built on it. We're not going to get into any of that today, but dictionaries are very flexible and very dynamic, I guess, and Python builds everything around that. So, be a good idea to look into dictionaries. Tuples and sets, I'm not really going to go into much. Python doesn't really support multiple return values out of a function. We haven't gotten into functions yet, but one of the ways it does it is using tuples. Tuples are just kind of like a record type. So you would say 1, 2, 3, Jason. So you can see the parens. It's similar pattern. You had the brackets for lists. You have the curly braces for dictionaries. You have parens for tuples. It's a little bit of an ambiguity with the grammar. There's situations where what if you want empty tuple, you can't just do empty parens. Or what is it? A single item. Yeah. You have to have a comma at the end of it, because if you just do a single item like that, the parens are used for precedence instead of for declaring a literal. So, but it's very similar to the lists and dictionaries. You might say, well, tuples kind of look like lists. Why would I use a tuple? Tuples are immutable, whereas lists can mutate. So if you want to say, this is the canonical set of things for this record or whatever, and I don't want it to change on me ever, you would use a tuple. There's obviously a lot of uses for all the data structures, but that's one that just comes to mind. But yeah, lists, I would say you would use lists a lot more because they're more flexible. You can add, append, do stuff like that. Sets. So you saw before with the curly braces that was like a dictionary. Well, it's only a dictionary if it has the colons in it, key, colon, value. If you just have a series of values, it converts that curly brace into a set. But again, sets, they're good for stuff like doing intersections, differences, unique, stuff like that, set operations. I already went over the indexing and slicing notations. Comprehensions is something, say you have this list of things and you want to transform it into a different list. So if you do range here, range is a built-in function that will return a list of those values incremented from 0 up to the value that you give it. So that's a quick way to get a list of integers. But say I wanted from 0 to 19, I wanted those values multiplied by 2, not the original values. You could use a comprehension to do that. You just say x times 2 for x in range 20. You can see instead of getting the original value, I got it multiplied by 2.
Can you add something or prepend an IP or 3 octets in front of that whole list or range?
Yeah, to prepend, is it insert? Onto a list.
I would just do addition.
Oh yeah, yeah. If you have 2 lists and you want to prepend one in front of the other, you can just use addition. So L was the what I assigned that list into, and if say I wanted to add something in front of it, say it was a number or the string 127.0.0.1. I could just add that with my original list, and the result of that expression is the concatenation of those lists. There is a IP address library that I'll get into later, but it allows you to do all these things with IP addresses that think you guys would get a lot of use out of. So that's comprehensions. Arithmetic operators, addition, multiplication, division, subtraction, exponentiation. It's all pretty much self-described. Division, 1/ is integer division. So if you have like 1.3 divided by 1, you'll get the floor of that. Or, sorry, you have 3 divided by 2. Instead of getting like a float, you'll get, rounded off down the floor of it. So if you want integer division, you have to, have one of the operands be a floating point number. If you want floating point division.
You can do is it the double slash?
I think that's the force integer division in the feature language. The double star, the single star is for multiplication, the double star is for exponentials. So if you do 2 to the power of 5, 32, Whereas a single star will just multiply 2 times 5. So that's all the arithmetic stuff. White space. So now we're getting into more like higher level constructs, like block type stuff. And with the blocks, Python uses like white space to indicate blocks. So you can't have variable white space. So I'll give you an example here. So say I was like if name, remember that name thing that we had before, is equal to JSON. This is an if condition. It takes an expression that if it evaluates it true, it'll execute the block that precedes it. So your block here, let's just do 1 + 1 print hello. You can see how I have to keep this stuff indented at the same level with the same white space. If I do something like this, it's going to give me like an indentation error. So you want to just make sure your indentation is correct. Something that like annoys a lot of people is a significant white space in Python. But once you do it correctly and learn to do it correctly, it's not really a problem. Just when you indent stuff, just make sure you're consistent in your indentation. Conditionals and logic operators. So you saw here I did equality. So I'm testing to see if name is equal to JSON. Currently name is equal to 1, 2, 3, 4, so that's going to be false. So if I just do what I did up here, see how it evaluates to false. Well, if you want to do something based on that evaluation, that's when you use if. So you say if that expression prints hello JSON. But it's not. But if I assign JSON back into there, you can see how it evaluated that, it came out true, and ran the block below it. Some other operators that you can use instead of equality, you can use any like logical operators like and, or, not. You can combine stuff like say not. So that evaluates the false. So JSON is truthy, and then not JSON is falsy, and then it short circuits to false. So you could do, like true and false. Well, that's not ever going to be true because, this is all just like, logical stuff. One thing that you can do is identity checking. So you can say like, this is that instead of equality, which is value checking. Something that's really useful is in. To say we had that list before, it's called test list. Say if I want to see if the number 3 is in that list, I could just say 3 in test list and it says true. So if I did something like 32 in test list, false. So you can do membership checking that way. You can do the same thing with keys of a dictionary. So we had test dict, and then say I want to see if the last name key is in there. So I do last name in test dict, true. Do first name, false. That's all logic and condition stuff. Looping, so there's two different types of loops in Python. You have while, which takes a condition. So I say while true, or let's do something that's not, screw it. While true, print, wow. So it's gonna print wow until the cows come home. So you have to control C that. If I did wow false or something that evaluated to false, like obviously this would never evaluate. It would skip that. The other type of looping is for. So use for iterating over stuff. So you saw before there was this thing called range that you gave it a number and it gives you all the numbers in that range. So if I did for number in range 10, print number to the power of 5. So that's how you loop over things. And you saw before with the comprehensions, I did something similar. Comprehensions are expressions. The for allows you to iterate over something and give it an entire block of statements for that, iteration. So you could say, instead of just doing one thing here, we could do for number in range, print number times 5, also print the number divided by 3. So you can see I can do multiple things inside that for block. So we got functions and built-in functions remaining. And then we're going to get into the pragmatic stuff.
By all means, ask questions.
Yeah, if you guys have any questions.
Move fast.
Yeah. If I wanted to run something in Bash in the middle of a .py script, what exactly do you do?
So we'll get to that here, but if you want to skip ahead a little bit, there's something called subprocess, which you can use to spawn off a subprocess, a child process. Or you can use this thing called Envoy, which is a little bit easier to use, but it's a third-party package you have to download.
Subprocess doesn't exist.
It does.
It doesn't.
It does.
It doesn't.
Does Python have any way of shelling out without using subprocess? I know it has
I think
like.
it's just
You
backticks.
can just do.
Well, that's like other languages have backticks, but
I think even.
Yeah, I thought you could. We got some scripts to do it.
no, this is just this like evals like Python.
It does.
I think. Oh, maybe I can't like use the import system in here or something. Let's just do dir dict. Yeah. So backticks are like evaluation, whereas I think maybe it's import os dot
System.
or import sys.
No, OS. Not system.
There you go.
System.
Sys.
And here you can do who am I?
On a roll.
Oh,
You need
I-
bad information.
Who am I?
Yeah.
For sure.
So this gives you the standard out and then
Yeah,
followed by the
no.
return code.
That just printed down, and then.
Yeah, that's
Oh,
right.
okay. So this is so
This is just for running it. You won't get like the output, but it'll run the command
it'll give you the exit code of the process as the return.
on.
Did you run like LS or something?
You know you can do that too. Spaces. Learned that the other day.
What is who?
Who is like who is on the system?
Who is on third?
There's also W. You beat me to it, Jason.
So
LS.
WMI.
What's that?
WMI.
Yeah, you can probably do that. I don't know. Yeah. Actually, no. So
Yeah.
this is the standard out, and then this is the return,
Yeah.
the exit code of the process. If you do something like exit 3, exit 3. How do you do an exit code in Bash? I don't know. You can see like if it gives you an integer that's other than 0, it's an error. And if it gives you 0, it's non-error.
Why am I getting name OS is not defined?
What's that?
Import OS.
Import OS, yeah. Anything that you're like putting a dot onto, usually it's like a package that you have to import.
Is there an easy way to see what's available to import as well or not?
Well, if you want to know what's in the standard library, the stuff that you don't have to install from a third party, just go to docs.python.org. And then there's this thing called library. You go there, it gives you like everything that's in the standard library. Usually if you just Google like what you want to do, it'll tell you what you need to import. Sys and OS are kind of like system packages that use a lot, like path manipulations in there, a lot of stuff.
Yeah.
I found this one pretty easy. To read some AU files a lot.
Really? Yeah. Yeah, Python, they say like Python's like batteries included. It comes with all this stuff like as part of the standard library. So if you have Python, you have all this stuff. And you can do a lot with it. Some of it's a little crufty and it's not the best solution.
What is web browser?
You never see that?
No.
You can do import web browser and web browser.open. And then you give it a URL.
No shit, that's
Google.com.
Wow, that's super
And it opens up Google.com in your web browser, but apparently it doesn't work on mine.
I think last time Joe showed it.
Yeah, it didn't work on his Mac either. I don't know. It usually
The
works.
security on there.
Maybe it needs to be like a fully URL.
It's a hidden web browser. Nobody knows it.
No shit.
Mine
That
works.
is cool as hell.
That is awesome.
How have I not known about this?
Yeah, it works on.
Creates the session.
Maybe because my browser's already open. I don't know.
Yeah, mine's open.
What's that?
Mine's open. Just Google.
Yeah, it's always worked until I wanted to show people, and then it just doesn't work. So mileage may vary on that one. Have you seen import anti-gravity?
What?
Hold on, guys.
Oh, it was showing up on my other display. That's why it wasn't working, because I have two displays. If you import anti-gravity, it takes you to the XKCD comic about that one. There's also import. What's the stupid thing?
All these macro.
What's the one that's like the Zen of
I
Python?
think it's like
obvious.
5-year-old
For what?
HP that I got for free.
No, that's not how it
It's not
Giant
on
macro.
This.
So this is these
No.
Oh, that's cool.
So yeah, there's no like canonical list of things that you can import. You kind of just have to.
There's like a massive, there'd be a massive list, I guess.
If you want to know how it finds everything, if you import sys, there's sys.path. Basically, it goes to every one of these directories and like looks in those directories for modules and packages. So if you go to every directory and list all those out, you'll know everything you import.
Excellent.
You can see there's like zip files that's like eggs and zip files. It can actually look inside the zip file to pull out modules.
Is that what an egg is? Like some sort of
Yeah,
package?
egg is
the
basically
way
a zip
you
file.
package Python.
Yeah. Well, no,
What is
now it's a wheel.
What?
Yeah, have you seen the WHL wheels?
Oh yeah. I don't understand that.
Anyways,
Because
there-
like a baby snake, you put it, it's in an egg.
Yeah.
But eggs are just zips.
everyone's back, so let's get into functions. So you see like all the stuff that we did. All the stuff that we've been doing is kind of just like on the global level. Like we're just doing a bunch of statements in sequence and playing around with stuff. If you want to have code that you can call multiple times and like reuse and reference, or say you just want to group operations, you can use something called a function to do that. I'll just write out a simple function here. So the syntax of it is def, because you're defining a function. And then you give it the function name, so I'm going to say caps. And then it's going to take an argument. You could take positional arguments like ABC, or you can take keyword arguments like x is equal to none. But the whole idea here is that you're receiving stuff into this function. So I'm going to take a string. I'm going to call it my string. And then everything that you do in Python that you indent, you have to precede that line with a colon. That like denotes that what comes after that colon, it's going to be indented. They call it something like a suite is what they call it. But basically it's like all those statements are grouped to that function. So you put a colon there, and then in here is where you put all your statements. So let's do some things. Let's print the string, first of all, or my string. And let's go ahead and print my string dot lower. So lower is a method on string that just lower cases the whole string. And then I'm going to return my string dot upper. Is that the method? So that'll upcase all the characters in the string. And what I'm doing here is I'm returning that instead of printing it. With functions, you can reach out into the system and do things, or you can only do things on the arguments that were passed to you. Those are like different styles of like writing stuff. Like pure functions don't do anything other than don't do anything to the system. They only do things to the arguments that are passed to them, and then they return the result. So this is how you return stuff from functions. So now that I have this function defined, it hasn't been ran. In order to run it, I just type in caps with the parentheses that calls the function. Now I'm going to do it without any arguments. You can see it gives you, if I can spell it right, it gives you a type error. Caps takes exactly what argument. So I'm going to give it that argument. So I'm going to say Jason King. So you can see it printed the string like we told it to. It printed the lowercase version of it, and then it returned the capitalized version of it. So you can assign that return value into a variable. So I could do like RTN is equal to caps. So you can see the print still happened, but the return value, instead of being put into the console, it's now saved as RTN. So everyone cool with that? Everyone grasps that? So the whole idea of a function is that you're just grouping statements, for reuse, so you can call them multiple times. I could do something like in that list comprehension that we were doing before. So range 10, I could say caps stir x, or what do I want to do, char x, stir x, and range 10. Yeah, so there's no capitals there, but let's get up in their range. It's like 50 to 70 or 80. Somewhere around there. There you go, you got some capitals. You can see it's still doing the printing too for everything. So we got that caps function, and now we can reuse it in all these different places. We don't have to repeat those statements over and over again. They're grouped under that function. So covered how to define them, how to call them. In Python, functions are first class, which means that the function itself is a value. So you can have functions that are like higher order functions. That basically means that they take functions in and return functions themselves. So it's kind of like your function isn't something that's static, that's never changes, that's defined once and never changes. It's something that flows through the system. You can assign it into variables. You can do operations on it. So that's like a feature of Python. The Lambda, so when we were defining a function before, we used the def keyword. Lambda is another keyword that you can use to define functions. So this is a function that just returns the value that you give it to the power of 3. And I can assign this into, I just call pow3. And now I can call pow3 and give it 12. Or I can give it 85. So you might ask, what's the difference between the lambda form and the def form? Well, lambdas are expressions, so you can use them inline. So it's a little bit shorter form. You don't have to do this indentation stuff, There's limitations to lambdas, in that they can't take blocks. I mean, that's the reason why they're there. They're also anonymous. You see, before when we defined a function, it had a name. Well, what if we want a function that doesn't have a name? Well, you could do that with a lambda. You can just do lambda x power to 3. And now it's just like an anonymous function. You don't have to give it a name. Some script boilerplate. So a lot of times when you're writing code, if you want it to be importable and you also want it to be ran as a script, that's where you use this like boilerplate. It's basically saying if name, which is the name of the current module, is equal to main, which means that the module is running as a script, then run this main function. I mean, you don't have to put a function there. You can just say if name is equal to main, put these expressions here, or statements here. And so when I import this, none of this will get ran. But when I run this file as a script, all the stuff that's under that condition will get ran. It's just a little boilerplate. You'll see that in a lot of scripts, like down at the bottom. The module will define a bunch of functions, a bunch of classes and stuff. And then at the bottom, it'll have some logic for running those classes and functions as a script. Argument parsing and stuff like that. So that's just something to be aware of. The built-in functions, these are things that, there's a lot more built-ins than I listed here, but these are some things that you might want to keep in memory. Dir we covered, dir and help. They basically, dir gives you all the attributes of an object. And then, so we had OS, which is a package. So if you do, or module OS, if I do dir on OS, it would give me all the things that are inside of it.
Dir is short for directory.
Yeah, it's kind of like ls. You're listing all the things that are in there. Help is the built-in documentation system. So you do help on any object. So if I do help on OS, like I showed before, it'll give you the man page type thing. Vars on OS. Forget how this differs.
Vars will tell you what's
The value.
The value of it.
Yeah, so instead of just giving you the keys, the things that are in there, it'll also give you the values, what they point to. Len, we had that test list before. If we wanted to determine how long that test list is, we can just do len on it, and that'll give us how many, from 1, counting from 1, not from 0 this time, how many elements are in that list. You can do len on the dict too. You can do len on any iterable, anything that you can iterate over. Like this gives you how many keys are in the dictionary. But anything you can iterate over, you can do a len on, I'm pretty sure. Or I think it has to implement under len. Maybe not everything, but most things you can do it on. Min, max, and sum are really useful. So say I want to get the minimum of our test list. See if this works. I don't even know if it will work. 1. So min was if we looked at test list, We had 1, 2, 3, and then some other things. So 1's the minimum value of that list. If we do max, it'll give us probably 3, maybe one of the objects, I don't know. Hello, so hello apparently is the max. But if you did like a range here, if you did like max range, so 11 was the maximum of that range, and min would be 0. Sum, so if you want to do a sum over that range, it'll just give you all the elements in that list added together. So that's kind of like a factorial, 12 factorial, or 11 factorial. Range we covered. It just, you give it a number, it produces a list. Enumerate's kind of nice. So say you want to enumerate, or you want to iterate over our test list, you would say for element in test list. But say you wanted to also get the indexes for that, you use something called enumerate, which will give you a tuple. And I'll just print out these things for you. So print, I'm going to print I and EL. So you can see it gave us all the indexes along with the values. So that's what enumerate does. It takes any iterable and enumerates it for you. Locals versus globals. So almost all the stuff we've been doing in interactive interpreter is on a global level, but when you're working with functions, you have those arguments that you're passing in. Those are called like your locals. So you kind of want to do most things locally. You don't want to be writing and reading from global state, because if you have multiple things writing and reading the global state, it's confusing. When you're reading code, you want to have like everything that that function's operating on like close to it. So you want to use locals instead. There is a built-in called locals, which it won't be any difference between this and globals in our global context. Pretty much the same thing, but if you're inside a function, so let's do def L test, and I'm going to receive A, B, C, and D, and I'm just going to print the locals. So if I do L test 1, 2, 3, 4, it'll print out its local variables. If I did print globals here with a G test, it will print out everything up here, everything that's globally available to it. There's also a scope called closure scope, which you can reach out to if you have nested functions, but we'll get into that. Eval, we kind of covered during the break. You have this like backtick thing where you can put in a Python expression and evaluate it. Well, you also have this thing called eval. It's kind of like a little bit of a metaprogramming thing where you can evaluate code and then return the result, but don't really need it. Input and raw input, you'll probably use a lot as doing scripts and stuff. So input, won't go into why it's called that, but really the one that you want is a raw input. So what this does is you give it a string, you say enter your first name, and then it'll actually print that string to standard out and then wait on standard in for you to type in your first name. And then it'll return what you typed in. So it's kind of like a way of reaching out in a shell script to the users and saying input this. If you don't pass everything in through standard in or through arguments to the script, at runtime, if you want to reach out to the user and ask them for something, that's how you do it. Repr is another really cool built-in, so you can repr on really anything. And basically it'll give you like a Python representation of that. So it's kind of useful. Shadowing. So when you define like locals in a function, those locals will shadow globals. So you kind of go from the local scope all the way up to the global scope. So if you have something called in your local function called dir, like it's going to shadow that built-in. So right now, globally, we have like, what? Give me a weird look.
Using the word in its definition.
Yeah, well, so we have this built-in called dir, but if we have a function that has a local called dir, it's going to shadow that built-in. So the built-ins aren't, you know, they aren't the truth of all dirs. Like you can have other dirs that aren't the built-in dir. So when you say dir, you don't always necessarily mean like the built-in dir. So if I do like testers here, it's going to print out what I give it instead of printing out the built-in dir. Dir. That's shadowing. That's about it. So, any questions on functions and stuff?
Does that effectively mean that there are no special reserved terms?
There are some reserved words in Python, but effectively none of the built-ins are reserves. Stuff like class, you know, def, stuff like that, those are like reserved words in the language, but Python really doesn't have that many reserved words. And if you do ever come into contact where you want like a variable that's named after a reserved word, or even a built-in, the convention is to use an underscore at the end of it. So this is going to be like, you know, your dir. Or if you want something called class, CLS is used, or sometimes they do KLAS. That's kind of stupid. Yeah, the standard library, I don't know if I told everyone about this, but basically, like, if you go to docs.python.org and then go to the standard library section, like, this has everything that is included in Python, like, by default. And it's a lot of stuff.
Glob.
Yeah, it's like a glob thing. That might be useful. So, you know, like, when you're doing bash, you have, like, those little, like, glob expressions that expand out to, like, other files. This allows you to, like, do that in Python. Regular expressions. If you want to do regular expressions, it's import RE. RE is the package name. And then you have, like, you know, replace, substitute, find all, split, search. You have all these different methods that you can use to do different things with regular expressions. But let's get into more of the pragmatic stuff. So I was going to cover working with files, just some simple file I/O and the shelling out and standard in, out, and error. And then the rest of it, really, it's like whatever you guys want to do. So let's do the file stuff first. So say I want to open this file. So I'm going to do that simple HTTP server thing. Just so we keep track of how many files I have. So I'm going to do an open on myfile.txt. If you give it a argument, you can say like the mode you want to open it as. So this is write. So I'm going to open up myfile.txt in write mode. And I think by default I don't even have to close it. I think it creates the file, like touches it for you. So now I have myfile.txt. If I look at that myfile.txt, there's nothing in it. But if I just do f is equal to underscore, so I forgot to save off the file handler for this. So the underscore allows me to recover that. So now that I have a handle on it, I do f.write, and I'm just going to write in my name is Michael. I just spell King. Like that. So if I go over here, depending on whether it's been flushed or not, it hasn't been flushed. Alright, so we're going to have to do f.close, which will flush all of the writes off the disk, hopefully. And there's my name is Michael King. I think there might be a flush method on f. So if I do dir, or let me just do help f one thing I didn't mention is that in the help stuff, if you do like slash, it's kind of like man pages. You can search. So there's a flush method I could have called, but I chose to call close. You always want to call close on the file after you're done with it, just to make sure that file handler gets returned to the operating system. It's like an operating system resource. All right, reading. So if you open up a file similar to the way we did before, but instead of giving it that second argument, we're just going to leave that off. Or you could put R in there if you wanted to. But if you just leave it off, by default it's read. And then you can do f.read, which will read everything from the beginning of the file on. So you get my name is Michael Kane. Read lines. We'll read in all the lines as a list. I don't think this will work because I already read everything. So it gives me an empty list. So I have to f.seek, I think, to 0. E-E-K. I know how to spell. And then I can read lines and I get all the lines back.
Yes, you can.
He's British. I don't know how they spell Michael Caine. Another thing you can do, I have to seek back to the beginning of the file. But another way you can like iterate over a file, you can say for line in file, and then you can say like print line times 2. So yeah. Already covered writing and closing the file. You always want to close your file.
Why don't you have to typecast it like we did before? Or,
Multiplying by 2 just does.
That's a good question. Yeah, you can multiply a string, which seems weird that you can do that, but you can.
Okay.
It's like if you want to have in your program like a bunch of asterisks or something to separate shit.
Yeah, so you do like 80. Terminal's 80 characters in method.
79.
79. So this is order of operations. You just have to group the precedence of these operations like that. So yeah, we didn't close our file, so we got to close it. And you might be thinking, oh, this is like horrible. I have to like close my file. I always have to remember to do that. Well, there's this like thing called a context manager in Python, and it has this little like with statement, and it's basically like it closes the file for you. That's all you really need to know. So if you do like with open my file as file f.write data, when you're done with, when you dedent that with, it'll close the file for you. You don't have to worry about it. So, file not open for writing. Oh, derp. So I need to do the right here. Obviously, I didn't test this code before I put it in the presentation. But now you can see like that data should be there somewhere. That data. Another thing we saw is that I wrote, but I didn't append. Like I wrote over it. So if I wanted to append, I think it's A. And now I can write new data. And so this will have the old data and the new data. And I haven't written it yet until I do 2 enters there. Data and new data. Alright, so that's files. Shelling out with Envoy and Subprocess. I'm going to show you pip real fast here. So I'm just going to get out of Python. I'm going to do pip install Envoy. You might want to try this on your laptop. See if it works. Basically, it reaches out to PyPI, downloads the latest version of Envoy, and installs it on your computer. So now that we have Envoy installed, I don't actually remember how to use this. So.
Just envoy.run.
Yeah, something like that. So if you go to the GitHub page for any project or wherever its project is, stored at, you usually see like a README with how to use it. So import Envoy, envoy.run, and then you just give it the whole pipeline of bash stuff that you want to run, and it gives you the result. So we're going to do envoy.run, or sorry, the import first. Envoy. to store the result in something called R. Say Envoy. I'll get it right one of these times. I'm just going to say, who am I? And so that creates a subprocess, runs it, and then returns a result. If you do r.status code, I think, it'll give you the status code of the process. And then r.std out is going to give you the standard or something like that. Underscore out. And then stdn will give you, or error. We'll give you standard error. There wasn't any standard error there. So. That's pretty much how you shell out. And you can get complicated with it and pipe stuff in and do all that stuff, but yeah. So Python has a few different ways of like formatting strings.
Only has one dot format.
So yeah, the only string formatting I use is like the dot format method. So I give it a string and then I call dot format on it and I give it the things I want to go into these little parens. So I'll give it like test and we. So you can see how it took these arguments and formatted them into this string. It's really useful when you're doing like templating and stuff like that. Like,
if you're gonna pass arguments into Envoy.
Yeah, like just off the top of my head, like the zone files that we build for our customers, DNS, like there's a header to that, and it takes a bunch of arguments that need to be formatted into it. So use this to format, the zone file data into the zone file. There's also this thing in the standard library called Subprocess. It's pretty easy to use. I would recommend you just do the, I think it's called P call, or maybe it's call. And then you give it a list of all the command and arguments. It's a little bit harder to use, so, but it's there. It's in the standard library, so you don't have to pip install anything. And then the last thing I wanted to cover here with files and stuff is standard in, standard out, and standard error. Everyone knows those things.
Standard in, standard out.
Standard error. You're funny, Zach. All right, so I'm just going to open up a Python file here. Vim sc call it dn test. So I'm just going to import sys, which is in the standard library, and then do sys.standardin.read. I'm just going to read it into a variable called data, and then I'm going to print it out, and I'm going to print it out 4 times. Print is actually writing to standard out. It's a way of writing to standard out. You can also do sys.standardout.write, but print is a little bit more fancier and easier to use, obviously. It's a keyword in the language. So I'm just going to write that out. And then, clearly I didn't test this. So just going to echo a string into that Python file. You can see how it wrote it out 4 times. It's pretty simple. So that's how you use standard in, standard out, and standard error. So you can pipe stuff into your Python programs and send it out to error or to standard out.
Can you take iterations and write those into a file?
What are iterations?
So you remember going back to, if you look at the HIP chat, I asked you the one question where how to prepend the first 3 octets onto a IP or range. And so if I want to generate a list of IPs, I want to take that and write it to a file. How would I do that?
Let me show you like a naive way of doing that. So let's see. Say we're gonna pipe in the /24, like the first 24 bits. We're just gonna pipe that into the program, and then we'll allow it to generate 0 to 255, the remainder, and then we want to write that to a file, or just write the standard out. So let's go ahead and just write a program to do that. We'll call it ipgen.py. So I'm going to import sys.standardin.read is going to give us the first part of the IP. I'm just going to call this, we call it network, the network bits. And then we're going to generate the host bits. So range, we already know it's a 0 to 255. That's going to give our hosts there. And then we could say for host in, or sorry, for host in hosts. And I'm just going to imagine I have a file here and I'm writing to it. f.write, and I'm going to write the network, and I'm going to write that plus a period, because there's a period in between them, and then that plus the stir of hosts. And then the only thing we're missing here is that file. So I'm just going to back up one space here and do with.
You can do it in there.
I could do it in there, but
Oh.
a lot more churn. With open. Actually, instead of writing it, let's just put it to standard out. Print. And then we can redirect it to a file if we want to. So let's see if this works. So I'm going to echo the network, which is 10.0.30, and then I'm going to pipe that into Python ipgen. You could do ipgen.py if you do the hash bang thing at the top. And that worked. So we have a new line in between it. So if we did the f.write, we wouldn't have that. But because...
No, it's the echo.
Oh, the echo?
Yeah, strip
On this guy?
Yeah, so what happened was what echo passed in is what you gave it and the line at the end. So Python has this function called strip, which will just strip out white space on the left and the right side of the string. So we'll take out that new line.
Yeah. So let's try it again. That's not what I wanted. Okay. So now we have all the IP addresses in that range. Obviously, this doesn't really work for doing other complex things with IP ranges. For that, I should probably just show you right now. There's a thing called IP addresses. If you do pip install IP address, I think it's called.
This is a reason to use Unicode literals.
Yeah. So pip install IP address, and then you just do import IP address. So you got this IP address library now. And you can do something like a, I think the easiest way to do is IP network. So this is a thing, you can give it an IPv6 network, you can give it an IPv4 network, but say I want to iterate over a 10.0.30.20 or /20, and I want to get the first IP in there. So I just do 1. Does not appear to be IP. Oh, that 30.0 has host bits.
24.
I'm going to do a 24 because I don't know how networks work. So that'll give you like the first IP address in there. You could do -1, same thing. You can do more complicated CIDR formats in there. I mean, you can basically give it any type of range. You can do a /20, but I think you need to do like 0 here, right? Yeah. So I'd give you the last IP in this network. Or you can do, if you want to iterate over all those in the network, I just need to save off this network. I call it net. And then I say for IP and net, I could say print IP. And I just print them all out. Another thing you can do is test for membership. So say I want to see if this IP is in that network. You could say IP address dot IP underscore address. Forgot an S here. And then you give it the one you want to test for, and then you can say, is that in my network? I'll say true, because it is. Let's say I did like 95 or something. False, it's not in there. So you can do membership. There's a lot of stuff you can do with this library. I've used it for a lot of things. It's actually part of the standard library in Python 3, but in Python 2 you have to do the pip install. But if you just look at the documentation here, you can do a whole lot of stuff. You know how IPv6 has multiple ways of representing an address? You can give it an IPv6 address, and you can say, I think it's .expand or .pact. Reverse pointer. Oh, I didn't even know you could do that.
Nice.
So yeah.
So do PTR records.
Oh, sweet.
So I've always manually wrote code to do that. Apparently it's in the library. So.
That'll help Jay out.
You can see how it works with IPv6 address too, which is really helpful, because that shit's hard.
So we're going to get that done next soon, right?
Yeah. So one thing... Is it not in? Yeah, this is the... Yeah, this documentation's for Python 3, and that's probably why I wrote that to do it, because like, do Python 3.4, I think. Import IP address objects. Still has not.
Said it was in 3.5.
So why?
Oh, I don't have 3.5, so
Nobody does.
yeah,
Oh, man.
it's coming. All right, you gotta wait.
8 years.
These are nice though. Is multicast, is broadcast. You know, like you can do stuff like that. I did that for when we're generating all the IP addresses. Break some. I did that when I was generating the IP addresses for IPMI, because I wanted to make sure that, you know, a device didn't get a broadcast or network IP. Is loopback, is link local. There's a lot of stuff in here. If you want this is the Python 3 version. If you want the documentation for Python 2, you can do this, but it's not in here, I don't think. Yeah, so you're gonna have to just Google for IP address Python, and then instead of going to the Python docs, you just go to it's on Google Code here. It's called ipadder.-py. So this documentation is more representative of what's available in 2.7 today. If you want the 3 documentation, you can just look at docs.python.org. So that's a little bit more like useful to you, you know, as like networking people. You people. Regular expressions, I didn't really go into much detail. And screen scraping, I included it in the notes here, a PyCon talk for screen scraping. And Zach said that he uses this thing called Scrappy to do screen scraping. I figured maybe that might be useful to you guys. I don't know, like, we didn't really cover the requests library, I don't think, did we? So I don't have that yet, so I'll just pip install requests. And then if you import requests, you can do request.get give it a URL. I'll just do, hopefully this works, I don't know. Yeah, it needs this, like a scheme or whatever. So it gives you back this response object. And then you can say response.status code. If you wanted to see the status code. So it's 200. Or you can say response.data. What was it? Content. So that gives you back all the HTML. That's kind of useful for screen scraping. So you got the HTML and now you want to like pull stuff out of it. Well, this doesn't give you like a semantic parse DOM of the document. So in order to do that, you need to use stuff like this Scrappy, I think, does it. Or you can use Beautiful Soup. I've used Beautiful Soup before. Allows you to give it CSS selectors and XPath selectors to reach in and grab stuff out of the DOM. But yeah, I would check this PyCon talk out if you want to get into screen scraping. That's all I got. You guys have any
I got a lot
anything
of
you want to
Yeah.
help with or anything?
Hey, I got a question. I'm sorry, go ahead.
Yeah.
You were asking something.
No, I was just gonna say.
Earlier when you were doing something or in the beginning, you like referenced an object and it like spat out like a what is like the object?
Oh yeah, so Python has a built-in called object. Its type is object, and when you instantiate it, it gives you back an object.
Yeah.
It's useful in a few cases, but most of the time it's just like an object.
Just do it in there as
Yeah.
like part of the example.
It doesn't really do anything.
Okay.
You can use it to identify things.
Okay.
So,
Like a pointer or something.
So you guys never really mess with that.
It's the base object.
Okay.
And so the only useful thing for this is like if you want to have a sentinel value, like
Yeah.
there's only one thing here.
Right.
Because you can pass in none functions and things like that, which usually says null, there's no value. But sometimes you want to actually say there's no value. But if you want to know if somebody didn't pass anything into that function at all, it's
Right.
like an object.
Oh, okay.
so like here, like I created two sentinel values, one called empty and one called full. And so if I want to signal like a function or something like that I'm empty or I'm full, I would pass in empty or full, and it would know that those are unique values in the system. Because if I say empty is full, like you can see they're different like objects. Like empty will not be anything other than empty. The only thing. So you can use it to signal stuff.
Okay.
And the only other time you really see it in the language is in Python 2. They have two separate styles of classes. One that's old and like one that's new. You definitely want the new one. And so if you're building your own classes in Python 2, you'll have to inherit from that object. That's kind of like telling Python that you want the new style classes. But in Python 3, you don't have to do that. Also, classes are a little bit like advanced for this talk, so I didn't cover them.
What about that? Is that like hexadecimal memory? Is that like a memory address or something? Or what is that?
Yeah, so that's the actual memory address of that object. So any, if you do ID of like anything,
Yeah.
it'll give you the integer value of the address of where
Okay.
it's stored in memory.
And you guys ever need that information?
No. Usually I just use the is to say, because the is literally does like ID, of this is equal to ID of that. But like, usually you just use is, which does that for you.
Gotcha.
I don't think I've ever really used ID other than to do stuff like this.
Cool. Just curious. I just saw that.
Like in
stuff up
C,
there.
you write on memory a lot, you have pointers and stuff, but
Yeah.
like in Python, you let the VM take care of all the memory and everything, garbage collected and all. So
I could see a use case if you were, for some reason, using that as a low-level code, but I don't see that ever happening.
Python, you want to stay as high level as possible and let the system do as much work for you as possible.